Hello, this is Mumshad Monambat and welcome to the YAML and JSON Path course. This is an introduction to the basics of YAML and JSON Path made by KodeKloud for the programming knowledge audience. YAML and JSON Path are a must-have prerequisite for anyone entering into the modern software development, cloud computing, data analytics, or DevOps world. Throughout this course, we get you up and running with these concepts using lectures and hands-on labs for practice. Thank you for joining, and I hope you enjoy the course. Hello and welcome to this lecture. In this lecture, we take a look at what YAML files are. If you have worked with other data structure formats like XML or JSON, you should be able to easily pick it up. Don't worry if you haven't worked on any of these. You should still be able to easily pick it up going through the coding exercises that accompany this course. A YAML file is used to represent data, in this case configuration data. Here is a quick comparison of a sample data in 3 different formats. The one on the left is XML, where we display a list of servers and their information. The same data is represented in JSON format in the middle, and finally in YAML format to the right. Take a minute to compare the 3 formats. Let's take a close look at YAML. If you take the data in its simplest form, such as key-value pair, this is how you would define it in YAML. Key and value separated by a colon. The keys are fruit, vegetable, liquid, and meat, and the values are apple, carrot, water, and chicken. Remember, you must have a space followed by a colon differentiating the key and the value. Let's take a look at how an array is represented. We would like to list some fruits and vegetables. We would say fruits followed by a colon. On the next line, enter each item with a dash in the front. The dash indicates that it's an element of an array. How about a dictionary? A dictionary is a set of properties grouped together under an item. Here, we try to represent nutrition information of 2 fruits. The calories, fat, and carbs are different for each fruit. Notice the blank space before each item. You must have equal number of blank spaces before the properties of a single item, so they are all aligned together. Let's take a closer look at spaces in YAML. Here we have a dictionary representing the nutrition information of banana. The total amount of calories, fat, and carbs are shown. Notice the number of spaces before each property that indicates these key value pairs fall within banana. But what if we had extra spaces for fat and carbs? Then they will fall under calories and thus become properties of calories, which doesn't make any sense. This will result in a syntax error, which will tell you that mapping values are not allowed here because calories already have a value set which is 105. You can either set a direct value or a hash map. You cannot have both. So the number of spaces before each property is key in YAML. You must ensure they're in the right form to represent your data correctly. Let's take it to another level. You can have lists containing dictionaries containing lists. In this case, I have a list of fruits and the elements of the list are banana and grape. But each of these elements are further dictionaries containing nutrition information. A lot of students new to YAML have reached out to me asking when to use a dictionary or a list. So let me explain this a little bit better. First of all, it is important to understand that all of what we discussed so far, such as XML, JSON, or YAML, are used to represent data. It could be data about an organization and all of its employees and their personal details, or it could be data about a school and all of its students and their grades, or it could be data about an automobile manufacturing company and all of its cars and its details. It could be anything. Let's take an example of a car. A car is a single object, and it has properties such as color, model, transition, and price. To store different information or properties of a single object, we use a dictionary. In this simple dictionary, I have properties of the car defined in a key value format. This need not be as simple as this. For example, in case we need to split the model further into model name and make year, you could then represent this as a dictionary within another dictionary. In this case, the single value of model is now replaced by a small dictionary with two properties, name and year. So this is a dictionary within another dictionary. Let's say we would like to store the name of 6 cars. The names are formed by the color and the model of the car. To store this, we would use a list or an array, as it is multiple items of the same type of object. Since we are only storing the names, we have a simple list of strings. What if we would like to store all information about each car? Everything that we listed before, such as the color, model, transition, and price. We will then modify the array from a list of strings to a list of dictionaries. So we expand each item in the array and replace the name with the dictionary we built earlier. This way, we are able to represent all information about multiple cars in a single YAML file using a list of dictionaries. So that's the difference between dictionary, list, and list of dictionaries. I hope you understood the difference between the three and when to use each of these. Before we head over to exercises, let's take a look at some key notes. Dictionary is an unordered collection, whereas lists are ordered collection. So what does that mean? The two dictionaries that you see here have the same properties for banana. However, you can see that the order of properties, fat and carbs, do not match. In the first dictionary, fat is defined before carbs, and in the second dictionary, carbs comes first, followed by fat. But that doesn't really matter. The properties can be defined in any order, but the two dictionaries will still be the same as long as the values of each property match. This is not the same for lists or arrays. Arrays are ordered collection, so the order of items matter. The two lists shown are not the same because apple and banana are at different positions. This is something to keep in mind while working with data structures. Also remember, any line beginning with a hash is automatically ignored and considered as a comment. We are now ready to head over to the coding exercises and have fun playing with YAML files. Hello and welcome to this demo. My name is Mumshad Manambath, and in this video we will get introduced to JSON path. We will start with a quick recap of YAML and the differences between YAML and JSON. We will then look at JSON path, where we see how we can get started with querying a JSON dataset that consists of dictionaries, lists and dictionaries, and complex data structure, and how to apply a criteria to our query. And finally, we will look at how to access the practice exercises associated with this video and how to navigate through the test. Note that this is for the absolute beginners, so we're going to go slow and start with really simple examples and use cases, and you will then get to practice what you learned and test your skills. So let's get started, and before we begin, remember to subscribe to my channel to stay up to date with new videos like this. In one of the earlier videos, we got introduced to the basics of YAML. We saw how YAML was used to represent data in a structured format. You gather information about an object, in this case a car, convert it into data and store it in a YAML format, which is a format that can be easily read by humans and one that can be easily parsed through by machines or programs or code. So what's the difference between YAML and JSON? Well, they're one and the same thing. You can represent the same data in almost the same way in either of these formats. While YAML uses indentation to organize data into lists and dictionaries, JSON uses braces or curly brackets. A set of properties defined with the same indentation in YAML form a dictionary, whereas it is everything within a pair of curly brackets in JSON. While in YAML we use a dash to denote an item in a list, in JSON we use square brackets to define a list and each item within the list is separated by a comma. You can easily convert data in YAML to JSON and JSON to YAML using an online converter or a simple program. The website JSON2YAML.com helps you to easily convert a JSON data into a YAML format or vice versa. All programming languages have support for reading and writing in either of JSON or YAML format. For the remainder of this video, we're going to work with data in JSON format. Now, that doesn't mean that this is not applicable to YAML. As we just saw, data in YAML can be easily converted to a JSON format with a converter. So let's get into the topic of today's discussion, JSON path. JSON path is a query language that can help you parse data represented in a JSON or YAML format. Just like query languages in popular database softwares like SQL. For example, if you're given a table of data, you could run a query against it to 1. Extract only certain fields like color and price of cars, 2. Extract certain rows from it like all information about a blue car, or 3. Extract certain fields of certain rows like the price of a blue colored car. So for any given data, you apply a query and you get a result, which is a subset of that data. Similarly, in the JSON world, JSON path is a query language that when applied to a given JSON dataset gets you results that are subset of that data. For example, in this data that represents the color and price of a car, use the query car to get the color and price of it. Say for example, we have information about a bus as well. To retrieve details about the bus, use the query bus. What if you only want specific fields from within each of these? Say for example, the color of the car. Use the query car.color in that case. The dot notation in the query helps you select a particular field within a dictionary. Car is a dictionary and bus is another dictionary. To get the price of the bus, use the query bus.price. Let us suppose the car and bus are encapsulated within a dictionary named vehicles. Now, how would our queries need to change to get the same results as before? We now have a parent dictionary vehicles, then the car and bus, which are child dictionaries, and then color and price, which are properties of the car and bus. We would now say vehicles.car to get the car details, vehicles.bus to get the bus details, vehicles.car.color to get the car's color, and vehicles.bus.price to get the bus's price. So that's how the dot notation is used to extract properties of dictionaries and dictionaries of dictionaries in JSON data. However, there is something still missing. If you try to use these queries now, it won't work. Let's go back to our previous data, the one without the vehicles in it. Our JSON document has car and bus in it. As you can see, they are encapsulated within a pair of curly brackets. And as we said before, anything within the pair of curly brackets is a dictionary. So car and bus are two properties of a dictionary or two dictionaries within a dictionary. But what dictionary? What is the dictionary's name? The top level dictionary, which has no name, is known as the root element of a JSON document. The root element is denoted by a dollar. We had vehicles earlier, but we don't have anything now. So we will remove vehicles from our query and use dollar to denote the root element. And that's the right way to form a JSON path query. A query created for a JSON document with a dictionary at its root should start with a dollar like this: $.car, $.bus, $.car.color, $.bus.price, etc. Going back to the data with vehicles in it, vehicles is now a dictionary within the root dictionary. The queries should now be $.vehicles.car, $.vehicles.bus, $.vehicles.car.color, and $.vehicles.bus.price. Great. But there is one more thing that I haven't mentioned. The results you see here on the right, well, that is what you would expect, but that is not exactly how you get it. All results of a JSON path query are encapsulated within an array. So when you run a query, that is what you get. The same result that you expect, but encapsulated within a pair of square brackets. So just remember that any output of the JSON path query is available to you within a pair of square brackets. Let us now look at lists or arrays. Here I have a list of different types of vehicles, like car, bus, truck, and bike. As you can see, there are no curly brackets, so there are no dictionaries. This is a simple list of names of different vehicles. The root element in this JSON document is an array, denoted by the square brackets. How do we get the first element in this list? To get a particular element from a list, use the square brackets in your query and specify the position of the item you want inside it. The indexes start at 0, so remember that the first element is at 0, the second one is at 1, the third is at 2, etc. And of course, always remember to start with the dollar symbol for the root element. So to get the first element in my list, I say $0. To get the fourth element, I would say $3. If I want the first and the fourth element, I could do 0,3 within the square brackets like this. Let us now look at dictionaries and lists. Here I have a data of a car, its properties, color, price, and wheels. Wheels is a list that has 4 items in it, each one being a dictionary. Say for instance, we have a goal to develop a query to retrieve the model of the second wheel of the car. As always, our query starts with a dollar symbol for the root element. The root element of the object is a dictionary denoted by the curly braces. So we know our query has to start with a dot following the dollar symbol. The dot is for the dictionary. Within the root dictionary, we have the car dictionary, so that's next in our query. Within the car, we have wheels. In the current state, the query would return an array of all the wheels. But that's not what we want. We just want the second wheel. So how do we get the second element in the array? We use the square brackets and specify the position of the item within the array. The second element is at position 1 as the index starts at 0. Note that we did not use the dot here as wheels is not a dictionary. It is an array. We now have the second wheel details. But that's still too much information for us, and that's not what we want. We just want the model of the second wheel. The detail we have is a dictionary, and you can get its model by adding .model to our query. Finally, let us look at applying some basic criteria or conditions to our query. So why do you need criteria or conditions in the first place? Here I have a set of data, which is basically a bunch of numbers. What if we want to query numbers based on certain criteria, such as list all numbers greater than 40? How do we do that? Well, we start with the dollar symbol for root element, and since the root element is an array, we use square brackets. Within the square brackets, earlier we were able to just give the position of items in the list, but in this case, there could be thousands of numbers in the list. We want to define a criteria where we say, get me numbers that are greater than 40. So check if each item in the array is greater than 40, and if it is, return that number to me. And that has to go within these square brackets. Now, of course, it's not going to be this verbal, so the check if part can be replaced by a question mark followed by a pair of brackets. This is used to specify a criteria or filter. Within the brackets, we say check whether each item in the list is greater than 40. From this, the phrase each item in the list can be replaced by the @ symbol. The @ symbol in a criteria means each item in the list. So our query is finally dollar followed by the square brackets. Within the square brackets, we use the question mark to specify a criteria. The criteria is always defined within the curved brackets. And in this case, the criteria is at greater than 40, meaning items greater than 40. Similarly, you can use other operators like at equals 40, at not equals 40, or at in a set of numbers like 40, 43, or 45. So that would return all the numbers that are either 40 or 43 or 45, and at not in a set of numbers. So that would return all those numbers that are not 40, 43, or 45. So those are a few operators of the many available with JSON path. So going back to this example where we have a car with 4 wheels, you're now asked to find out the model of the rear right wheel of the car. Now, looking at this data, you could simply find the model of the third wheel because by looking at it, you know the rear right is the third item in the list. So you write a query to pull the model of the third wheel. But this may not be true all the time. Maybe for the next car, the person who was responsible for entering this information into the database followed a different order. The rear right wheel is now the second in the list. So our query now returns the model of the front left wheel, which is not desired. So our query no longer works for us. For our query to work with data entered in any order, we can use a criteria to identify the wheel which has the location property set to rear right. So instead of hard coding the position of the wheel, we replace it with a criteria. We first add the question mark with brackets to specify a criteria, and then inside that we say check if each item has the location property equal to rear right. And there we have our criteria. Well, that's a quick introduction to JSON path. Head over to the practice exercises section and try to practice what you learned. For this, head over to the URL kodekloud.com/p/json-path-quiz. It will open up a quiz portal interface. On the left top side, you have your questions. Below that, you have the space to type in your answers. In the lower half, you have 2 sections. The one on the left is your source data, and the one on the right is the expected output. Your goal is to create a JSON path query that, when applied to the source data, gets you the expected output. You can start typing in your answer in the space provided. As you type it in, your query is automatically applied to the source data, and the result can be seen in the section in the top right corner of the screen. This will help you compare the output of your query to the expected output. As soon as you develop a query that gets the expected output, the question is marked as complete successfully, and you can move on to the next question by clicking on the Next Question button. You can try different queries as many times as you want until you get the right answer. You will be able to see the result of the query instantaneously in the section in the top right corner. In case you're not able to figure it out, click on the Show Solution button and it will show you the right answer. Well, good luck with the practice test. If you're interested, watch me solve the test in my next video. For more information about JSON path, check out github.com/JSON path for a full documentation. If you'd like more advanced use cases to be covered, please leave a comment below and I will try to get it done. Well, thank you so much for watching, and don't forget to subscribe to my channel for more videos like this. Goodbye. Hello and welcome to this demo. My name is Mumshad Manambat and this is a continuation of the earlier JSON path video where we got introduced to some of the basics of JSON path. In this video, we will get introduced to some of the advanced options available while working with JSON path queries. Let us use the same example that we used before. In this dictionary, we have two child dictionaries, car and bus, and each of them has two properties, color and price. To get the color of the car, we use the query $.car.color, and to get the color of the bus, we say $.bus.color. What if we want to get all different colors? For example, someone were to ask you to retrieve all the different colors of all the different vehicles available in your store, you would say, instead of saying car or bus, you could replace it with a star or wildcard, meaning any. So your query would be $.star.color. Similarly, to get all prices, you would say $.star.price. So a star wildcard within a dictionary means all or any property of a dictionary. Let us look at it in a list. In this case, we have a list of wheels. Each wheel is a dictionary that has a model and location. So this is a list of dictionaries. We know that to get the model of the first wheel, we would use the query $0.model. Similarly, to get the fourth wheel, we would say $3.model. But what if we want the models of all the wheels? Instead of specifying a position within the list, you could say star to say all wheels. Within an array or a list, using the wildcard star means all items in the list. Let us try to mix the two now. I have a dictionary of car and bus, and each of them have information about two wheels. I have removed the details about the other two wheels and their location to save space on the screen. The JSON document at a top level is a dictionary with two child dictionaries, car and bus. Within the car and bus dictionary, we have wheels, which is a list with information about two dictionaries, each containing model. To get the model of the first wheel of the car, we say $.car.wheels_of0.model. To get the model of all the wheels of the car, we say $.car.wheels_of_star.model. We replace the wheels position in the array with the star to mean all items in the list. Similarly, to get the model of all wheels of the bus, we say $.bus.wheels_of_star.model. To get the model of all the wheels in both car and bus, we replace the car and bus with a star to mean any. We say $.star.wheels_of_star.model. So if you're required to use a wildcard and if you're not sure, I would recommend following a step-by-step approach. As you can see here,
If you were asked to find models of all the wheels in all the vehicles, you might have found it difficult to come up with this query directly the first time. So try to follow a step-by-step approach where you solve one portion of it each time until you can finally put it all together, as we did here. We first tried to find the model of the wheels of the car, then the bus, and then we were able to put them together by using the wildcard. Well, that's it for now. Head over to the practice test and practice working with wildcards. Hello and welcome to this demo. My name is Mumshad Manambath and this is the continuation of the series of videos on JSON path. In this video, we will get introduced to some of the advanced options available while working with JSON path queries, specifically lists. We learned earlier about lists. Here's the list of top 10 brand names on Forbes. To get the first element, we say $0. To get the fourth element, we say $3. And to get the first and the fourth element, we say $0,3. Let us look through some additional options. What if you want to get all names from the first to the fourth element? For that, you can use the semicolon. To say 0 to 3, you will use the query 0 semicolon 3. But note that when you say first to the fourth element, it does not include the fourth element itself. It means from the first up to the fourth, not including the fourth element itself. If you want to include the fourth element as well, you should say 0 to 4. We now have a query that gets the first 8 elements from the list. What if we want every other item? For example, say we want Apple, Microsoft, Facebook, and Samsung. You can use the step option by adding another semicolon and by specifying the number of hops to take after each item. A step value of 2 means increment the counter twice before fetching the next item. In other words, it means skip or hop over one item. What if you want the last item on the list? We know that the items in the list have indexes starting 0. In this case, for 10 items, the indexes are 0 to 9. To get the last item, which happens to be McDonald's, we could say $9. But what if the list was smaller or larger? Then this query will not work. So how do we develop a query that always returns the last item in a list, even if the number of items in the array changes? Just like how you have indexes starting at 0, from the first item in a list, you also have indexes start at -1 from the last item in the list. The last item is always at -1, no matter how many elements are in the list. So to always get the last item, you could say $(-1). You see, that's how I'd expect it to work, but that does not work in all of JSON path implementations. For certain implementations of JSON path, you must specify this in the start and end format with a semicolon. So you should say $(-1) to 0. This means start from the last element and all the way to the end. You can also simply leave out the 0 and it would assume it to be 0. Similarly, to get the last 3 elements, you could say $(-3) to 0 or leave it blank. Well, that's it for this lecture. Head over to the practice test and practice working with lists in JSON path. Hello and welcome to this demo. My name is Mumshad Manambath, and in this video we will look at how to use JSON path in Kubernetes with the KubeCtl utility. We will start by discussing why you might want to use JSON path in the first place. We will then look at viewing and interpreting KubeCtl output in JSON format, post which we look at the different steps involved in using JSON path with the KubeCtl utility. We then look at several JSON path examples and then go through loops before finally looking at custom columns and sort functionality of KubeCtl. Once done, you will go through a set of practice tests where you get to practice what you learned through some fun and challenging exercises. So let's get started. And before we get started, remember to subscribe to my channel for more videos like this. Now, before you begin, you must know how to work with JSON path. So that's a prerequisite. If you have never worked with JSON path queries before, check out the videos and practice tests on that first. They're available for free on my YouTube or on the KodeKloud website. If you have worked with it already, let's continue. Also, it's good to first practice JSON path on Kubernetes dataset so that you know how to navigate through it before actually working on JSON path with KubeCtl utility. We also have a set of exercises on working with JSON path on Kubernetes dataset, so make sure you go through that as well. In this video, our focus will be on how to use JSON path queries with the KubeCtl utility. So why JSON path on the first place? When you're working with production environments for Kubernetes, you will need to view information about hundreds of nodes and thousands of objects like deployments, pods, and replica sets, and services and secrets, etc. And you will be using KubeCtl utility to view information about these objects. You will often have requirements where you will need to print summary of different states about different resources. You will want to view specific fields of all resources, query data about the resources based on different criteria, etc. Viewing such information by going through thousands of these resources is an overwhelming task, which is why KubeCtl supports a JSON path option that makes filtering data across large datasets using complex criteria an easy task. But let's take a step back and understand how the KubeCtl utility works. We know that the KubeCtl utility is the Kubernetes CLI. You use it for reading and writing Kubernetes objects. Every time you run a KubeCtl command, it interacts with the Kubernetes API through the kubeAPI server. The kubeAPI server speaks the JSON language, so it returns the requested information in a JSON format. The KubeCtl utility, on receiving the information in a JSON format, converts it into a human-readable format and prints it out to our screen. During that process, a lot of information that came in the JSON format is hidden in an effort to make the output readable by showing only the necessary details. Now, if you'd like to see additional details, you could use the -o wide option with the KubeCtl get command. This prints additional details, but again, this is not complete. There are still a lot more details that are not part of this output. For example, the resource capacity available on these nodes, the tains set on the nodes, the conditions of the nodes, the hardware architecture, the images available on these nodes, etc. Well, you can see them if you run the KubeCtl describe command, but what if you want to see it like a report? For example, say I'd like to see the nodes and their CPU counts in a tabular format like this, or the list of nodes and the tains set on them, the architecture, or say print the list of pods and the images they use. None of the built-in commands can give me these in this format. That's where JSON path queries can help. With JSON path queries, you can filter and format the output of a command as you like, and that's what we will see in this lecture and in the practice exercises that follow this video. In order to get started with JSON path in KubeCtl, you must follow these 4 steps. First, you need to know the command that will give you the required information in the raw format. For example, if you need information regarding nodes, then you must use the kubectl get nodes command. If you need information regarding pods, you must use the kubectl get pods command. We have seen a lot of these commands throughout this course, so that should be easy. Once you identify the command, inspect its output in JSON format. For this, add the option -o JSON to the command. It will print the output in a JSON format. This is the same format of documents you worked with during the JSON practice test on Kubernetes objects that I mentioned in the beginning of this video. The next step is to look through the structure of the JSON document and form the JSON path query that will retrieve the required information for you. For example, to get the image, you would use the query .items of 0, .spec, .containers of 0, .image. And finally, use the query you developed with the same kubectl command. To do that, use the -o JSON path option and pass in the same JSON path query that you just developed. Remember, you must encapsulate the JSON path query within a pair of single quotes and curly braces, like this. We now have our kubectl command with the JSON path query. So if you're a beginner to JSON path and to this kind of logic, then I would recommend strictly following this approach, where you first view the JSON version of the output, copy the output to a JSON path query evaluator like jsonpath.com, then play around with it until you come up with the right JSON path query, and then move that query to the kubectl command. With that, you should be able to come up with JSON path queries to pull useful information like the below. A JSON path query of .items of star .metadata.name with the kubectl get nodes command gives us the names of the nodes in the cluster. A query of items.status.nodeinfo.architecture returns me the hardware architecture of the nodes. And status.capacity.cpu returns me the count of CPUs on these nodes. Finally, I can merge these queries together into a single command. For example, I could use the first query to get the node names and add the query I used to get the CPU count to it. And that gets me both the results in a single command. That's good, and I can get any information from the JSON output as long as I can figure out the right JSON path queries for it. But that's still not pretty, is it? That's not how I want it to look. So let's look at some of the prettifying and formatting options. In this, I have two types of information in the same line. I can insert a new line by adding the new line parameter in between the two queries like this. The /n is for new line and /t is for tab. We will now look at loops using ranges. This may be a bit advanced for some users, so don't worry if you don't fully get it. From a certification and exam standpoint, we've covered what we need, but I'd like to cover this as well before we wind up. With the queries we have built so far, we were able to get different sets of information like names of nodes, the CPU counts, etc. in this format. But this is not what we really want. We want it to look like this one on the right. The node names in one column and CPU counts in the other. This is where we use loops to iterate through items in a list and print properties of each item. We will focus on the JSON query part alone for now. When I run the kubectl get nodes command, I get a list of items, each item representing a node. So I want to be able to say, for each item or a node, print the node name, then insert a tab as a separator, and then print the CPU count followed by a new line character. This will get me the results in the format I want. To specify the for each statement, use the range keyword. Range items of star means for each item. To print the node name, use the same query we built earlier, .metadata.name. Then to add a tab, add the /t keyword. Then to print CPU count, use the query .status.capacity.cpu, and then to add a new line, add the /n keyword. Finally, end the loop using the end keyword. Merge it all into a single line and pass it as a parameter to the JSON path option of the kubectl command. You can also use JSON path for printing custom columns with KubeCtl. At times, this is an easier approach when compared to using the loop method. Let's take the previous example where we used the JSON path option to print node names and CPU capacities. What we really want is to print them as separate columns, one column with the node name and another with the CPU count. Instead of using the JSON path option directly with the command, you could use the custom columns option of the KubeCtl command. The custom columns option takes a set of column name and JSON path options. For example, for the first column, the column name is node. The JSON path corresponding to the node name is .metadata.name. Note that you must exclude the items section of the query as the custom columns assumes the query is for each item in the list. This prints the first column with the given column name and its data. Similarly, you can add additional columns by adding additional column and JSON path pairs separated by a comma. So we add the next column named CPU with its data at .status.capacity.cpu. Much easier and cleaner. Again, for this too, I would recommend first coming up with the JSON path queries for each column and then putting them together in the command. Finally, JSON path can also be used while sorting objects by specifying the sort by option. The KubeCtl command comes with a sort by option where you can sort the output based on the value of a property from the JSON formatted properties of each item. When you run the KubeCtl getNodes command, specify the JSON path query we developed earlier as is in the sort by option to sort based on name or CPU count. Well, that's it for this lecture. Head over to the practice test and practice working with JSON path and some advanced KubeCtl commands. And before you go, don't forget to subscribe to my channel for more videos like this.